Can you explain the alpha particles a bit more? Alpha particles are literally helium nuclei. 2 protons and 2 neutrons bound together in a stable magic number of protons and neutrons, so that the strong nuclear force is holding them together really, really tight. And what that means is that that becomes a very advantageous way for a radioactive nuclei that's massive to get rid of a whole bunch of mass and a whole bunch of energy all at once. And when that occurs, it's a tunneling effect. So it's a quantum mechanical process where the alpha particle will tunnel through the barrier. The funny thing about that barrier is that you think that an alpha particle having a positive charge would have a massive force pushing it out from that positively charged nucleus. What happens, though, is that the reason why the alpha particles don't just spontaneously all come out of a radioactive nucleus is that when the alpha particles were first put in there from stellar supernova that created them, that created the heavy elements, or neutron star mergers, or whatever it was that created that heavy element, when those alpha particles were first put in there, there was a very large amount of energy that had to be overcome, a barrier, a Coulomb repulsion barrier that alpha particle had to go through to get in there, and that energy has to be given back, because once that alpha particle got in there, the strong nuclear force had it bound. And so you got to give back that energy to break that binding from the strong nuclear force to get that alpha particle out. When that alpha particle comes out, again, it's a helium nuclei, but it's going to have many mega electron volts of energy. It's going to be a high energy alpha particle. And what that means is that as it's running through materials, it's running through, traveling so fast that it's just going to get its electrons stripped off right away. It's going to be running into other materials and the electrons are going to get stripped off. And so it's just a bare alpha nuclei plus 2 charged helium nuclei. And then as that's pummeling through materials, say it's a solid material, it's going to be jostling the atoms that are around it, causing them to move around. An analogy, a way that I like to think of it is like if you have a black hole moving through the disk of a galaxy, it's not going to run into any of the stars. There's too much space there, but the stars are going to get jostled around near it. So it's going to kind of punch a hole there. In other words, it's going to have a higher density around the path traveled and a lower density right through the center. And that's kind of the same thing that alpha particles do when they're going through material. They'll jostle the atoms and kind of move them around because the attractive force of that positive charge is going to push off, or sorry, the repulsive force of that positive charge is going to push off the others. And they're going to be jostling around in there as that alpha particle pummels through. And it's basically going to kind of drill a hole through a material, leaving a number of vacancies right along the path and a number of interstitials on the periphery of the path that alpha particle went through. And that's usually how the alpha particle does damage in the materials. But an alpha particle has a very short range. It's depositing so much energy so fast that it just doesn't travel very far through materials. For example, in a typical solid material, it might only, say a 5 MeV alpha might only travel, say, a few tens of microns. And if it's only traveling a few tens of microns, that means it's not even going to pass through the dead layer of your skin. So alpha particles on your skin aren't really harmful at all. They really don't do anything. They just deposit their energy in the dead layer, into dead cells. It's when alpha particles get inside of your body that's a much bigger issue, because tens of microns is, quite a few cells, and it's basically depositing all of its energy in those cells. So it's doing a lot more damage to living cells if it gets inside of you. And I hope that was a quick little useful survey on alpha particles. So thanks for the question. Thanks for watching the video. Have a good day.